Hello, today I will be discussing hydrostatics, linear momentum, buoyant force, and Bernoulli's equation. So this first problem, what we're trying to do is find the pressure at the bottom of this tank. And so for this one, all we need to do is find the density of our fluid. We need the pressure that's given at the top of the tank. We need gravity, and we need the height of the fluid, and that should get us our hydrostatic pressure at the bottom of the tank. And now for the second part, our linear momentum, we find the anchoring force. So this ends up being the force that's pushing against there, which is the velocity times the density times the velocity of the individual and the area. And we also have the second velocity of the water coming out, which is providing a force in the other direction. So we count for both of these. We use our mass balance to determine that the flow is the same. And afterwards we get the sum of the forces, and that should get us our force in the linear direction to anchor the individual. This problem has the buoyancy. This one we're going to sum up the forces to determine the terminal velocity, and to find the buoyant force, it is the volume submerged times the density of the fluid that's in times gravity. In this case, we will balance the forces and find the terminal velocity, and this should give us our final answer right here. And for this last one, we have our extended Bernoulli's equation. So this is set up via friction. The friction is caused by the particles, in this case it's rice, in the inside of the tank. And so we do the math on that, and that gets us our friction force. And from there we can determine the velocity of the fluid as it's passing through the substance.